Welcome to my channel, and today we will discuss the March 7th daily Leetcode problem. It's a pretty simple problem, finding the middle of the linked list. The straightforward approach with someone without any basic coding understanding might try is to find the length of the linked list and find the middle element accordingly, and again traverse to the linked list to that particular element and send give that as output. But there's an elegant approach which mostly interviewers expect from you. So let's try to solve using that. It is called a fast and slow pointer method or hare tortoise method or something else. But whenever I use the method, I generally create a king node. Uh, this is one of the common approaches used in linked list. So let's say it's called king is equal. It's a new node. So new list node. Let's say we can give a value -1. Okay. And this king node, the next value will be the head. So in this fast and slow pointer method, we will need two pointers. Let's call them as fast and slow. And both initially are at the king node. King and yeah, slow equal to and let's do a small analysis. Say for the example one, we have 5 nodes. Initially, let's try to dry run it. Yeah, I will just comment it out like this. Yeah. So initially fast and slow pointer are at the let's start indexing this linked list from 1. And initially, let's say the king node is the 0th index node. Fast is at 0 and the slow is at 0. What we do is we iterate 2 steps in fast and 1 step in slow, and this goes on. Still, we are able to go till fast is going able to go till not null node. So fast from 0 it goes to index 2, and slow goes to index 1. Then fast goes to index 4 and slow goes to index 2. Now fast can't go to index 6 because it doesn't exist there, and the slow stops there itself. So now the result is the next node of slow, because 3 is the middle element for 5 noded linked list. So slow next is the answer here. This is for example 1. And when we go for example 2, this is the another case where even nodes are there. In even nodes, they have mentioned like only in even nodes we have 2 middle nodes. Namely, here 3 and 4 are the middle nodes. They are asking the second middle node. So here the 4 is the second middle node. If we dry run in this, fast pointer is initially at 0 and slow is at 0. Next, fast is going to 2 and slow is at 1. Then fast goes to 4 and slow is at 2. Then fast goes to 6 and slow is at 3. Then fast doesn't go beyond that. 7 doesn't exist, 8 doesn't exist. So the result will be still here also. Slow next is holding the answer. Slow next is the answer because slow is pointing to the third node, fourth node is the answer. Here Slow is pointing to the second node, third is the answer. So here clearly, slow is exactly pointing to the integer half of the number of nodes. So when we had uh, 5 nodes in the list, slow is pointing to 5/2, which is 2 uh, in integer part. And when 6 nodes, it is 6/3, which is equal to, sorry, 6/2, which is equal to 3. Hence, what we do is, uh, so clearly in both conditions, even nodes or odd nodes, slow is pointing to the one node before the answer. So this is a very clear and good observation. Even if you explain it in an interview, this like this, it would be nice. So let's try to code it. So what decides that fast can move 2 steps? That is the next question. What decides fast can move 2 steps? One, fast next should exist. And the next node to that, fast next should exist. That's it. So this is a very simple analogy. So let's try to code it. I will just copy here. Yeah. So let's use a while loop. While fast next and fast next. You can either write it like this or you can write fast next not equal to null. Both works. This is like faster and like it looks neat, right? So what is the thing is, even if it's null, the statement gets false. So it's working. So now what we do is we iterate fast 2 steps. So it becomes fast next, and slow goes a 1 step. Slow goes to slow next. And when it comes out of the while loop, slow is pointing to one node before the answer. So we just return the next node to slow. Let's try to run it. Yeah, it works fine. Since we have dry run it before, I'm running it directly. So I recommend in an interview to dry run before uh, like finishing your code and showing it to your explaining it to your interviewer. Dry running without even the interviewer asked is recommended. So yeah, now let's try to submit it. Yeah, it works fine, and it's one of the like fastest approach. Memory, we don't need to care about memory here. We are not creating, we are just creating one node extra. Maybe that's why we have a very bad memory, but this doesn't matter here. We just have we go one extra space here. So that's it. That's this problem, and that's how you solve it in the right way. Thank you.